My name is Lane Martin. I'm currently a professor in material science and engineering and the chair of the department. We have a couple faculty here with us today to participate. Maybe I'll have a second to just let them introduce themselves. Mary, would you like to go first?
Hi, everyone. My name is Mary Scott. I'm a faculty member in MSE. And I think especially relevant to this information session, I'm also the associate chair for undergraduate studies in our department. So that means that when students have questions about substituting courses for one another, questions like that, or if you just wanted to chat about our curriculum and get some more information, I am someone that you can absolutely reach out to.
Great, thank you. Ting, you want to say hello?
Hey, I guess good morning, good afternoon, good noon, whatever you wanted to call it. Welcome to the information session. I'm a professor in both material science as well as chemistry. So my group does soft materials, and I'm trying to get the undergraduate curriculum in soft matter aligned on campus level. If you're interested in plastics, polymers, biomaterials, tissue engineering, all those good stuff, feel free to stop by. I'm also advisor for student with joint major between material science and chemical engineering.
Great.
Welcome.
Thank you. Andy, you want to say hello?
Hi there, my name is Andy Miner. I'm a professor of material science and engineering and also work at Lawrence Berkeley National Labs, which is just up the hill. I'm actually up the hill from campus right now at the lab. Work in the field of electron microscopy and metallurgy. And actually, I have a former community college student who is now an undergrad working in my lab right now.
That's right. I think that'll be a common theme. Many of us have had excellent students who have transferred into Berkeley. And Nicole, you're here. Did you want to say hello or not?
Sure. Hi, everyone. My name is Nicole McIntyre, and I am the manager of transfer success initiatives for the College of Engineering. So you probably received many, many emails from me over the last 6 weeks if you're registered. As a reminder, we have one last webinar, which is next week and with me. So thank you all for being here, and thank you so much to the MSE team for hosting this. This was our top rated, most favorited webinar last year, and it definitely swayed some people towards the MSE major.
Right. So with that great endorsement and no pressure, I think we can get started. I think I want to start by saying, material science is open for business. We welcome all of you to join us. We think we're the best department on campus and the best material science department in the world. And there's a number of things that will support us in some of those claims or close to. And we've had a long history of great success for transfer students who have come in and gone on to great future careers and lots of different disciplines and fields through our department. So what we're going to do today is kind of 3 parts. So we have set up some time to kind of just give you an overview and history of the department. Then the 4 faculty that are here will kind of engage with you in kind of open-ended conversation. We can tell you a little bit about what we do. We can talk about research. We can talk about how we got here, basically whatever you want to know. And then at the end, some of our students from our student organization are going to join us as well for this. And I also realized that Medina is here, and I didn't introduce Medina. Medina, do you want to say hello as well?
Sure.
Thank
Hi,
you.
everyone. I am the Undergraduate Student Services Advisor here in MSE. So usually students come to me with different questions about classes or like petitions, as like Professor Scott had stated, and just like all kinds of different things. I do some student hiring. So if you want to work maybe as a reader when you're here, you will be receiving emails from me to hire you. And just I'm here as a resource and to direct you to any other resources on campus if I cannot answer your question or if I think it's better suited elsewhere. So hope to see you here next year or in the next few years.
Yeah, agreed. Okay, thank you. All right, so if you're not in Berkeley today, I'll just say this is what it looks like every day. in Berkeley. It's a little cloudier today, a little rainier, but we'll take the rain. But typically a nice view to see. I'm sure many of you don't need an introduction to the campus overall, but we have this kind of dichotomy, right? On the erudite, fancy side of education, we're Berkeley, and we have this fancy, crest here. And then for the sports and other side of things, we get a little more crazy with the bears and these sorts of things. But we are one and the same, and we try to embrace these different aspects of life in lots of things. As for material science, we go way back to the start of the university, in fact. So this is a picture taken from the Berkeley Hills looking west. So the bay is way out here. And this was what campus looked like in, circa 1874. I think this building is still on campus, in fact. That's South Hall. Now, the charter year for UC Berkeley was 1868, and there were initially 3 technical colleges. One of them was the College of Mining. That is the department that directly translated into material science over the years. A few name changes later, and we ended up with material science and engineering. So that puts us at something a ballpark of about 153 years old for a department, which is pretty old for anything in the United States, I guess, in an academic sense. Now, another interesting thing about the history of material science and of Berkeley in general is that we have a long history of women being very actively engaged and playing very important roles. And one early woman who was very important to the UC system was Phoebe Apperson Hurst. She was married to George Hurst, and she has one rather famous son, William Randolph Hearst, who you may have heard of. She was also the first woman regent of the UC system, and she provided some of the earliest funds for scholarships for women at Cal, and actually funded a competition for a campus architectural plan in 1891. And at the time, there's kind of a few fun quotes about these sorts of things. At Oxford University, which at the time was apparently rather strapped for cash, a Latin order was quoted as saying, "There is brought a report that in California, there is already established a university furnished with so great resources that even the architects, a lavish kind of men, full permission has been given to spare no expense. Amidst the most pleasant hills on an elevated site, commanding a wide sea view, is to be placed a home of the universal science and a seat of the muses." So this is where, if you come to Berkeley and you come to material science, you get to be part of this, right? A home of the universal science and a seat of the muses. Now, even more connected to us is what's behind me in this picture right here. This is our home on campus. This is the Hearst mining building. And so with a gift of $900,000, so about 22 million in today's money, Phoebe Apperson Hurst commissioned John Galen Howard to erect some of the earliest buildings in the campus architectural plan. And they dedicated our building, Hearst Memorial Mining Building, to one of their family members, George Hurst, who was a plain, honest man and a good miner. And again, this was the mining school to start. So here's a picture of the building circa 1909. And as we go through the years, the cars out front seem to change. You can see we start to get slightly different types of cars out front, but the building still looks kind of classically timeless. Now, it was the cornerstone was laid in 1902, finished in about 1906, if I recall. Dedication the next year, relatively cheap by today's cost, but went through a very major upgrade in the late 1990s into the early 2000s. So we have a nice kind of home to call for the department. So has a beautiful lobby. This is a picture from the 4th floor looking into the lobby of the building. This beautiful light open space actually was inspired by this 19th century reading room in the National Library in Paris. So if you want a little taste of continental Europe while you're hanging out at Berkeley, you can come hang out in the lobby. And there's always somebody taking a picture, you can see. Even in the picture, there's a person taking the picture. So lots of people come by to see this place. Just some more gratuitous pictures. This is actually a picture of some of our shared student space. If you're doing research, many of the research groups have students who can sit in these areas. Okay, so a little bit more history about the department. There's some we've had some famous visitors over the years, and one person who you may have heard of as you're taking your physics classes and things like this is Ludwig Edward Boltzmann, as in the Boltzmann constant. He was an Austrian physicist and philosopher, a statistical mechanician, I think is the appropriate term for what he was. And he visited and taught during the summer of 1905, and he has a couple important quotes I think we should share about his time at Berkeley. So one, he said it was the loveliest place one can imagine. I think we all have a strong affiliation and feeling for Berkeley in that regard. But he had another one I think is even better, and we should just pass on, which is that unlike Berkeley, he said, Stanford University is laid out in a unified, architecturally attractive scheme that seems to me quite unsuitable for educational purposes. So we can never pass up a chance to take a dig at Stanford along the way. So this is, just a few things to point out. All right, now let's get up to the modern times here. So what's our promise to you? So our promise to you as the educators here in material science and engineering is that we're going to work with you to try to make you the best possible material scientists and engineers that you can be. And that means we're going to work within the constraints that arise, if any, to provide you access and support for your education, right? There's lots of stuff happening. We're literally living through a pandemic. We have wildfires and smoke and, who knows, but we'll figure out a way to kind of keep this going. We also will work to provide a safe, caring, and humane environment that enables every member of our community to grow and thrive and really succeed in their education. And finally, we'll seek a diverse student body, faculty, staff, and perspective as a critical part of what we think the mission for educating leaders and serving society as scientists and engineers really is, right? So this is kind of the philosophy of where the department's kind of coming from as we approach our education. Now, once you get here, we're going to really try to give you the best thing we can. We contend that we have an outstanding educational program. I think you have a very clear understanding that Berkeley overall is one of the top universities in the world. It's the #1 public university, #4 overall in the US News and World Reports. And that comes about not because, Berkeley is something special by itself, but because all of its parts are excellent at a very high level. The College of Engineering is ranked, typically in the top 2 or 3 in both undergraduate and graduate programs. In material science, we're in a similar boat, right? Typically in the kind of 2 to 3, 2, 3, 4 range for things. Occasionally it jumps up and down, but you get the idea that this is a, kind of a sustained level of excellence that we expect from our program overall. And what that means is we're trying to provide our students with a cutting edge education that balances kind of the foundational critical concepts of material science, but mixed in with kind of state-of-the-art cutting edge research and access to things that you maybe couldn't get at every other place, right? So it doesn't matter what kind of area you want to focus on. We have people working on these sorts of things. We have people who can really push the envelope and push you to learn new things in new areas in this field. Now, at the end, I think when you get here, we hope that you'll be part of, our excellent students that we really have. Our typical class sizes in material science and engineering are somewhere on the order of about 40 to 50. We might see a little bit of, fluctuation on that by the year. And that usually translates somewhere into the ballpark of about 150 total students, all told, plus or minus by the time we're done. This is spread across mostly MSE kind of consistent majors, but also with a handful of joint majors with Bio-E, Chemi, EECS, MECI, NUPE, these sorts of things. Now we also have connected with this a healthy graduate program that includes typically maybe 20 to 30 PhD students, 5 to 10 MS students, and maybe 10 to 20 MN students. These are master students of different types. So about almost equal sizes, about half undergraduate and half graduate student population at any time. Diversity in engineering is always a challenge. It's one that we continue to keep working on. But material science is usually doing okay compared to the rest of engineering, maybe not compared to how we'd like to be on the global scale. But our typical class makeup is generally in the ballpark of maybe 35 to 40% female students overall. And by the way, I should note, if you have any questions, just chime in or feel free to drop a question in the chat. Faculty members are programmed to talk for an hour uninterrupted. So if you don't say anything, we will just keep talking and making up more stuff to go on about. So you have to step in periodically. Okay. Now, we also have outstanding educators. So these are the smiling faces of our core faculty in the department. You've met 4 of us here today, but we have 18 core faculty across different levels, assistant, associate, and full professors. We have 10 named professors, and I will maybe embarrass her. Professor Mary Scott is our newest one. She literally found out yesterday that she got an endowed professorship from the College of Engineering for being an outstanding young faculty member in material science. We're very proud of that. The folks you'll be working with in class and in the lab are also well represented and well recognized around the world. So we have National Academy of Engineering and Science members. We have Presidential Early Career Award winners in Science and Engineering, MacArthur Geniuses, APS Fellows, MRS Fellows, TMS Fellows. Everybody's a fellow, right, at this point. So what this should point to is that these are really world-leading people in their field, and you get to interact with them, and they love to have interactions with you as students. We also have additional joint faculty. These are faculty members whose primary appointment is in another department. It could be physics, or a number of these folks are in physics and chemistry and things like this. We have adjunct faculty. These are faculty members who have their primary appointment at Lawrence Berkeley National Lab, who are expert scientists in different areas and then come to teach courses with the students and can even take students and do research with them as well. And then we have a set of lecturers, Chris Kmai and Matt Sherburne, who really focus a lot on the pedagogical side of things, the teaching side of things from our labs, and really innovation on the teaching side. So we really think we have a world-class education and lots of opportunities for you to work with leaders in the field of material science. Now, a little bit nuts and bolts. You met Medina already, and she's just kind of the tip of the spear, if you will, for our student advising and service efforts. We have 2 MSc Student Services advisors. Ariana Castro primarily deals with the graduate program, and Medina with the undergraduate program. So she's kind of your point of contact for many things. But we also have a handful of faculty advisors, each kind of with specialties in different backgrounds and areas that you can come talk to. Ting is one of those folks. And then the big boss there is Mary. Mary is the chief undergraduate advisor. So the buck stops with her for all sorts of curriculum questions and issues. And if you're ever having a problem transferring class or this, that, or the other thing, we really try to work as a advocate for you, right, to kind of help you navigate this. And we'll work with the College of Engineering, with Medina, to kind of sort out all these sorts of things. There's pretty much no problem that somebody hasn't seen, right? So we can figure these things out. So just reach out if you join us. We want you to reach out and get the help you need for these sorts of things. It shouldn't be stressful. Now this is part of our bigger department staff. So again, we have a department manager, Catalina Estrada. I just talked about Ariana and Medina. Chris Kumai helps develop our labs. Chad Southard is another person who helps us with our labs. So if you take some of our upper division undergraduate lab courses, you'll definitely see Chris and Chad running around. But we also have an individual, Jennifer Teverbal, who is kind of oversees and manages the building and the facilities around us. So these are all people who you might run into and can all help you find and navigate whatever you need about the department and about Berkeley. And I really think what I want to give you a sense of is that while Berkeley may be a very large school, right, a very large program, material science is a pretty intimate kind of close family, right? We're small enough that kind of everybody knows each other, and there's a lot of support structure there, right? So it's kind of, you get the best of both worlds. You get the best of, being at a big school that has all these different things, but you can be part of this department where it's much more intimate, and there's kind of a face-to-face kind of interaction to deal with things. And I think that's a real advantage of being in a department like ours. All right, now, this is a quick rundown of the curriculum for our program, and we can spend some more time on these sorts of things. So many of you will be coming in somewhere on this end of the spectrum over here, having finished most of your undergraduate requirements. We do and have historically tried to pay close attention to making sure things map to the credit that our transfer students have when they come in, right? And so even when we make some changes, we often typically make some exceptions to kind of keep it smooth and make the transition from one of the community colleges a bit more simpler, right? So if you have any questions about these sorts of things, or if stuff is going to mesh up, again, just reach out to us. We're very happy to talk about these things. But you're coming in at a great time as a transfer student into the curriculum, because you're jumping right into the really core upper division material science courses, which are going to really, in about 2 years, you're going to learn a lot of stuff. You're going to become, maybe going from knowing only a little bit from an intro level class to being a really high level functioning material scientist. Ting teaches our intro polymers class. Mary and Andy teach characterization methods and different things. I teach our intro class. I teach some properties classes as well. So we have a good perspective on these sorts of things. Now, the other thing I would point out here that's perhaps quite attractive is that we have built in quite a bit of flexibility. You can see these things listed as electives here and here and here and here and all over the place. What we found was that our students really wanted to be able to adapt their curriculum to themselves, right? What were they, what are they interested in? Where do they want to take it? And it's not like our students are taking underwater basket weaving for their electives, right? They're really taking challenging courses, but the courses that are meaningful to them. And we want to give you that autonomy to kind of find your own pathway. And you can talk with us and we'll give you some advice if you're interested in this, that, or the other thing. We'll get you to the right people so that you can find what those pathways are forward. You can tell us what your goals are. Where do you want to be? Do you want to go into industry, go into grad school, these sorts of things? There's no right or wrong path. It's just your path, right? And so we're trying to give you that option and that flexibility to do this. As part of that, we really tried to spend a lot of time and effort on thinking about what it means to be innovative, what it means to be cutting edge in education for undergraduates in material science and engineering. And as a leading department in the world, we think that's part of our responsibility. And so this is just one example. We've hosted national symposia about materials education. I participate as the chair in the University Materials Council, which is a collection of all the chairs, and we kind of exchange information about curricula development and things like this. And we really try to pay attention to how we kind of stay up with what are the needs in this community and how we're moving the programs forward overall. But the idea, I think, is that what we're really trying to do is get you exposed to kind of cutting edge concepts. So we'll make sure you know the foundational things, but then many of the faculty are bringing in, research examples and cutting edge things or data from, that they've just taken in the last couple months or something, and trying to mesh that with the foundational concepts that you see, so you can get that sense of how we apply these things. Now, we couldn't talk about coming to Berkeley without saying something about, the world-class research. So in our department, we have just a huge range of things going on. Something approaching about $20 million of annual research expenditures across the faculty, and very strong efforts in a whole slew of different areas. So pretty much anything that you're interested in, we probably have somebody or connections with people who can do these sorts of things, and we can get you to the right people if you're interested in doing research. And as part of that, you can then leverage the excellent facilities that we have available to us both on campus, right? Here's just some examples. This is the micro nano fab in Marvell. This is just across the Hurst mining circle from our building. This is Stanley Hall, where there's a microscopy facility. You can see Professor Miner here sitting on the desk, looking intently at some data on the computer here. But you can use these things as students, right? You get in there, you start trying these things out. And then the other thing about coming to Berkeley that we really hope you come and be part of this is that you have a totally unique opportunity to start to interact with researchers who also have footprints up at the national lab, and you can do big science. Professor Miner is sitting in his office in one of the premier electron microscopy facilities in the world, right? And you can learn how to use these sorts of things if you can engage with research and do these sorts of things. So we want our students to engage and participate in these aspects. There's a huge opportunity for you to do undergraduate research. I would say pretty much anybody who wants to do it will end up having an opportunity to do it. You just have to ask, right? You can end up in a whole slew of spaces in our department, outside our department, at LBL, maybe a little mix of everything by the time it's all said and done. How do you get involved in that research? Well, you do a little bit of research yourself, right? You spend some time, you learn about the faculty, their research, you maybe talk with their grad students, maybe you meet one of their GSIs in one of your courses or something like this, so on and so forth. Visit the websites, read some papers, decide what you're interested in and think about what parts of that really are meaningful to you. And then just ask, right? Ask the faculty lead for an appointment to discuss your prospects, talk with the GSIs, all these sorts of things. People are generally pretty, open. You're going to send some emails, maybe you won't get some responses, but overall, show up at an office hour, find a way to talk with the people. And if you show that kind of initiative, most of the faculty are going to say, all right, I'm going to give this person a shot, right? We'll see how they do. And it really open up your education in a new way. So you've got your classes, you've got your research, you've got all this stuff going on. And then before you know it, you're at the happy end of all of these sorts of things and you're launched into the next part of your life, right? So at the end of the day, I know you're not here yet, but I want to say, we hope you come to Berkeley and welcome to Berkeley if you do. And we hope that you really come join us here in material science and engineering and help us write a new chapter in our future, but also in your future as well, right? So, thank you for your attention. And, I want to open it up right now. Maybe I'll stop sharing slides here and just say if anybody has any questions, please throw them out there. Mary, Ting, Andy, and I are here to answer questions. Maybe we'll start with some questions and then we can kind of go into some other discussion from there. Anybody have any questions?
Yeah, I actually do. Hi.
Hi.
Yeah, do you mind speaking a little bit about research experience some students have had in the past?
Yeah, I think maybe we can all say something small about like one experience like our undergraduates have had. So in my group, I'll just talk about one that I recently had. This individual just started her PhD at Cornell. She actually started research with us the summer before COVID. Did a great job, kind of kept going. Then she happened to be from the Bay Area. So when COVID came, she was actually able to be in the Bay Area and we made her one of our essential workers. She was able to come into the lab while we were, on restrictions and had limited population density. And we're just finishing up the paper. I think it's the 4th paper that she's been a co-author on. So she became kind of the go-to person for one type of measurement that we had using a scanning probe microscope in the lab. So the undergraduates, we'll let you go as far as you want to go, right? Like you'll end up being kind of your own little like graduate student research kind of independent researcher. And if you have initiative and you have desire to do it, we'll let you expand. And I've seen students publish, 3, 4, 5, be co-authors on 3, 4, 5 papers as an undergraduate in my group over the years. So that's just one. She literally just started her PhD at Cornell this year, but we're finishing up the 4th paper with her as a co-author. Anybody else want to chime in with a story?
Why don't I share a slide with you? I think that maybe potentially have some images that will be helpful. Hold on a second.
Go ahead.
Here. Okay, all right. There's not only just the technical aspect, there may be potentially financial as well. So am I sharing screen?
Yeah, I see it.
Okay, all right. So here are 2 panels. What's going on? Do I lose everyone?
No, it hasn't gone to full screen, but we still see you.
Okay, is that full screen now? Or what do you see?
We still see the regular.
You see the regular? Do you see?
Yeah.
It's all right for me.
It's good. Okay, hold on a second. Let me share the screen one more time. PowerPoint. How is that now?
You have to swap displays, I think.
Okay, all right. This slideshow. How is that?
Now it's gone.
Okay, all right. That's interesting. All right, then you have to just go with whatever comes out in the screen. Going to put me as my presenter mode. Hold on a second. Let me just do it one more time. I think because okay, we'll do this. How's that?
Yeah, we can see it. It's
Okay, great.
Good.
All right, let's talk about this. So this is happened to be a project we are doing currently, dealing with enzyme embedded plastic. And on this panel here are 6 students that are either working with us. I think that there are 4 of them still working with us, and 2 of them already graduated. And they are co-authors for 2 manuscripts. And here are a few of them that move on in the last few years. And you know, they get into, they certainly did really well. And let me just show you one thing. We just won this Creative Future contest, and I want to point out that Ivan here was an undergraduate student in the group, and because we won some money, so he is going to be part of that. And if you get into this manuscript, you're going to see several of undergraduates are joined the co-authors on that front. So there's certainly a lot of opportunity. At least in my lab, everything was normal. I think at a given time, we typically have about 20 undergrad in the lab. That's just how it works out. It's beneficial on both ends. They will end up with different careers. Some decide going to a graduate school, some get into industry, some get into investment, some get into consulting. So by the end of the day, we provide a platform, and you decide where you want to go.
Yeah, I'll chime in and say that one thing that you folks who are considering MSE or are considering transferring to UC Berkeley might have heard is that the years go by fast when you transfer in, and that's also true of research. And I had an undergrad in my lab who graduated maybe 2 years ago, who told me, well, I've only got, it feels like I've only got 2 years here, and I want to try different things. I want to figure out if I want to go to academia or industry, and I might want to try out different research groups if I want to stay in academia. And I don't know how I'm going to manage all of that. But I just want to mention that that's okay. And I was very supportive of him, coming to me and saying, hey, I know I'm in your group, but can you write me a letter of recommendation for a different summer internship? Because I would like to have that different experience. And I would like to have that, that different item on my CV or my resume. And so even though it might feel like probably to him, it felt like he was juggling a lot, I personally was really supportive of him being in my group, but also seeking out those other opportunities that were going to be helpful to him. And ultimately, he did end up doing an internship away and coming back and working for me until he graduated. And then now he's a grad student at UCLA, which is great because that's my alma mater. So just a little kind of story that also I think captures maybe a concern that is common to transfer students who are interested in doing research.
Okay, I'll add my piece now. So undergrads have always been part of my lab, and some of what we do, for instance, up here at the National Center for Electron Microscopy, is really complicated. It takes a long time to sort of get qualified on the instruments. But there's a lot of things that have to happen in research before you get to those instruments. One of the most critical things is making samples. And one of the reasons is because to see atoms, to see materials at the atomic structure, you have to be very thin. And so anything you want to look at, you have to thin down somehow. So undergrads really get their first hand on research by working on sample preparation. The other thing that I have in my lab is mechanical testing. So we do a lot of metallurgy and breaking stuff and doing it with some pretty nice instruments where we have cameras that can look at how materials deform. We have some weird things like send electrical pulses through materials as we're pulling them, and over the years, different undergraduates have actually learned how to use the mechanical testing equipment and become actually the super users. So for 2 years, I had an undergraduate named Lily, who was the super user, would train. I mean, just like Lane said, she would train other people, graduate students and such, because she was around campus a lot. I mean, one of the things about graduate students, you're kind of all over the place, going up and down to LBL and maybe not in one spot, but undergraduates, because they take more courses, are kind of around more, actually. So I found that it's really nice to have undergrads just sort of in the lab, and they'll go back to the lab, and there's a nice table and a couch, and they'll do homework and meet students for problem set stuff, and just sort of be in the lab, which graduate students aren't always there. And so they can train people on the equipment. And that's kind of been really nice. So Lily did that for 2 years. Now she's a graduate student at Caltech. And right now I have an undergraduate named Thomas Greathouse, who's starting to serve in this role. Thomas actually went to Laney. He was a transfer. Probably everybody in our department knows Thomas. He loves to come to office hours, all of them, every minute, always. Very.
By the way, I do recommend you go to office hours.
I do.
It's very helpful.
And that's how you get to know people, and that's
how you get to know people.
And especially last year with all this, the mess of the pandemic. I mean, that's how I got to know Thomas. He was there every Zoom and asked questions, and so that's how you kind of get involved. And so he's just been around, and now he's going to be running this mechanical testing system. Kind of like the super user. It's interesting. Yeah.
Are there other questions that people want to hear about? So one possibility is we could have our faculty tell you how they ended up in material science, because it is not necessarily always our everybody's chosen path to end up in material science. If people want to hear about that, we could chat about that for a second. But if you have questions, please chime in. I don't want to take time away from the questions you have. So maybe I'll start about how I became a material scientist. So I am from rural Pennsylvania, halfway between Pittsburgh and where Penn State is in State College. And if you're unfamiliar with the map of Pennsylvania, there's not much there. And I liked chemistry and math. And so I was going to be a chemical engineer. Someone says, is there corn and soybeans? No, we're not quite the Midwest yet. So there is a little bit of corn, but no soybeans. But we have hills. So it's not flat either. And so I went to college. I started as a chemical engineer, and I really did not like it. No offense to my chemical engineering colleagues, but I felt like a glorified plumber, at least to start with. It just wasn't my bag, and it didn't like me. And I was 2 weeks from becoming a business major. And I talked to somebody who was my advisor, and they asked me what I wanted, what I liked. And I told them, and they're like, well, you want to be a material scientist. And I was like, I don't know what material science is. So I took the intro and I decided I was going to take research, as a freshman. I was like, I'm going to take the intro and do research. And if I don't like this after one semester, I'm out. I'm out of engineering and I'm going somewhere else. And the research I started doing my freshman year is ballpark exactly what my group does. I started growing films by pulse laser deposition as a freshman, and I hope my group does that now. So you don't know how you're going to end up in the field you're in, but once you find it, you'll find your passion and you'll kind of go forward. There's a couple other questions that came in while I was ranting on about this. Let me try to address some of them, and then maybe Mary and Ting and Andy can chime in on their pathways. Is there a basic overview of what material science is? Wow, that's a tough one. But I will say this. So at the basic,
Tetrahedron.
What was that? Yeah, the tetrahedron, exactly where I was going, right? So what we care about is the structure of the material. That could be the atomic structure. Where do you put the atoms? It could be the microstructure. How do you stack these things at maybe the micron scale or something like this? How that connects to and is interrelated with the properties, how that connects to and is interrelated with the processing, how we make the material. And then finally, what all that means for the performance of the system. So we care about some application at the end of the day, but we go all the way from this macroscopic application all the way down to maybe the atomic structure of the material. And folks like Professor Scott and Professor Miner, that's what they do. They fundamentally take pictures of where the atoms are inside of materials, and we use that to learn stuff about, you know, the properties and the performance that comes out of these systems. So a material scientist isn't just taking kind of a macroscopic view or a microscopic physics view. We're trying to take this kind of view across many length scales in a system about how structure, processing, properties, and performance all come together to describe what happens in the material. Others, you want to chime in on what material science is to you?
Somebody said in the chat, designer matter, and I really like that. It's sort of like you have the atoms that you have on the periodic table. Some of them are easier to get than others. How do you put them together, and what arrangements and on what length scale to design better materials for life on Earth?
I would say my group actually does designer matter. Like in my group, we can control materials down to a single unit cell. So in the growth systems that we have, we actually monitor the growth in situ and can watch as we grow a single layer at a time. And so then we'll put down a layer of A, a layer of B, a layer of C, then a layer of A, then a layer of B, then and we build up artificial materials that you can't just make in the bulk, right? So we literally make designer materials and try to have them do properties that we can't get otherwise out of materials.
Or maybe I can chime in about plastics.
Please.
Yes. So my dad wanted me to get into a business of making advanced small molecules. And the story he was telling me was that if you can make fragrance molecules that added into your fragrance, small amount can definitely go with a lot of values. Plastic is different in the very opposite end back then. This is, we'll talk about 20 something years ago. You look into the quantity. So I choose to go with a quantity. So I wanted to work with something I had to deal with daily. You just simply cannot get plastic out of your life. It doesn't matter where you go. Even when you first start with this little cell, grow into a human, your life is dictated by a piece of a long molecule that is DNA. So what do? I want you to go into the store and look at the price difference and look at what each individual pieces are made of. You're going to see polyethylene everywhere. But the price for a piece of polyethylene can go 15 cents a pound to $1,500 a pound. The reason is how you manipulate the material, how you process it. And if you happen to do a mountain climbing, you're going to see the rope you're dealing with is nylon. It's no difference from the pants, the shirts you use, but depends on how you process that long molecules. They can really, when you do mountain climbing, can hold your weight. So there's quite a drastic difference here. And I think there's a lot of challenges right now associated with plastic waste.
So I'm going to field a couple more questions, and then maybe we'll throw it to Andy as well. So one question was MSE versus MECE. How different are they? They are pretty different. Now there are portions of the Venn diagram that overlap between material science and mechanical engineering. We do care about the mechanical properties of materials, but whereas a mechanical engineer may take a more macroscopic, kind of statics, picture of the mechanical response of a material, we want to know what the microstructure, what the atomic structure is happening. It just so happens that Professor Miner is pretty good at that kind of stuff and looking at those sorts of things. Andy, do you want to say a couple words about your thoughts on MSE versus MECE?
Yeah, actually, so I was a mechanical engineering major as an undergrad, but that's because the school I went to, which was Yale, didn't have that many different departments. And so material science was just one course inside that major called material science. And it just happened to be my favorite course. And so that's why I went to graduate school, material science. And when I applied for graduate schools, and I'm gonna date myself, this is like beginning of the internet, it was hard to sort of find out about different schools. I was surprised there were schools that had whole departments called material science. And I'm glad they do, though, because it's very important to understand the difference between steel 1 and steel 2 and steel 3 if you're a mechanical engineer, because mechanical engineers will maybe look at, I'll just pick a metal or a polymer or whatever. And it's really important to understand the differences between them and what the properties and what happens and all that stuff. And so material science is at the core of a lot of things that mechanical engineers do, but it's much more based in science. That's what's actually great about our field. It's called material science and engineering. It's this great blend of science and engineering. Some places call it applied physics, what we do. It's basically physics and chemistry applied to real materials. And so it's actually really fun from that perspective.
So maybe I can chime in on that. I think material science is a foundation for many different disciplines. So the materials we do support bioengineer to do implant, to do drug delivery. The polymer, the plastic we do is supporting plastic electronics, which goes into EECS. And the materials we develop supporting additive manufacturing or 3D printing that's happening in mechanical engineering. And we are also intimately connected to chemical engineering. Chemical engineering is how to make a production of plastic, how you're going to deal with the heat transfer, mass transfer, etc. So I think the disciplines are all interconnected, and materials present a very important, I would say it's almost like a hub. Chemistry and chemical engineering make materials. Bioengineering, mechanical engineering, they use materials, but we are the ones can get you to have exactly the same material, but depends on how you process it, depends on how you blend them, depends on how you design them, put them all together, and then to, in the end, realize different properties. I think, my group, we work on drug deliveries. We work with people from bioengineering. We work with people from hospital. And then we do recyclable plastics, right? We put enzyme into the recycled plastics. And that's get into probably more along the direction of mechanical engineering, right? They're looking into the manufacturing, even civil engineering.
So hey Ting, I'm gonna do a rapid fire round here because we've got a couple questions that came in. So let me do a couple and we'll sort it out. So material science students going to grad school. Do most material science go on to grad school? It's about a 50-50 mixture, plus or minus a couple, 5-10% every year. We have about half people who go into industry. We have about a half people who go into graduate school programs. We've had people go into law school. We've had people go to business school. We've had people get into entrepreneurial stuff. So it's not necessarily that you're, only stuck doing these sorts of things, but, it's a pretty diverse job. Almost every company that makes something has a need for a material scientist, right? So there's a lot of opportunities in that regard. Another person asked, what about additive manufacturing? Absolutely. This is a very up and coming field. We actually have a offer out to a new faculty member who we hope will take that offer very soon, whose expertise is in additive manufacturing of very complex kind of designed architectures of materials to produce new types of properties. It's super cool stuff. This is a big push that's coming, and we're investing in that as many people are. There's another question: is there a certain focus in material science at Berkeley? Maybe some of the other schools in the UC system focus on different things. I think we're as being one of the top programs in the country, it's such a diverse field. We can't do literally everything, but we're doing quite a few number of things pretty well. I'd say electronic and functional materials, that's the stuff I work on, is something that we have a strength in. We have a very strong effort in structural materials, in materials characterization at various length scales, computational material science, soft and biological materials, energy materials. There's a number of things that we have, and we play part of a bigger ecosystem on campus too. So I think you can pretty much find whatever. I would never say we're just like an electronic properties or mechanical properties or this, that, the other thing. I think we're much more diverse than that. Our transfers allowed to minor. Medina, do you know? I think so, but or Mary?
Yes, transfers are, and I think Nicole had answered this as well.
Oh,
So
I'm sorry. I'm like maybe behind.
no, you're fine. So just double out there. Yes.
Okay. I think there's a question about, Chemi, maybe you were thinking about transferring to Chemi, but you think you might want to change to MSE. You're welcome. I mean, the difference here is Chemi is not in engineering, whereas, material science is in the College of Engineering. From our perspective, we're open, right? We're open for business. If you guys got into Berkeley, we would love to have you, right? Be part of the crew. So we don't have any problem. We don't have we're not impacted in a way that you can't get access. That would probably be something that's above my pay grade to tell you the answer to if you were transferring into the College of Chemistry versus into the College of Engineering. Maybe Nicole can chime in.
I can, yes. You really need to apply to the major that you plan to study. On the transfer level, the faculty review your applications based on how good of a fit they think you are for their major. And we check to make sure that you followed the assist.org page to take the right classes for your major. So if you're thinking about, oh, maybe not Chemi, MSE has persuaded me, I would really start talking to your community college counselors and looking at the MSE page of assist.org now, because if you wait until you're on campus, there is a really good chance that it might be too late to make that shift to a different college.
Okay, let me keep going with the lightning round here. Do EECS folks care about materials at all? In fact, basically the people who are EEs in material science, many in EECS, many of them are kind of material scientists at the end of the day, right? They're synthesizing materials. Now they're probably trying to use those materials for devices than the like, but they absolutely care about this because you can't make the computer function. You can't make the electronics function if you don't do this. So my research is such that we work a lot with people in EECS as we design devices. And often they'll say, oh, this is what we want the device to do. And we try to help come up with the material systems to enable that because they can't make it work right now. So there's a huge range of materials, everything from soft and polymer materials for packaging and things like this to electronic and functional materials and metals and everything that go into electronics. So it's a really complex materials landscape. Okay. Whew. Let's see. Did I miss any really important ones? Right now, there's a number in here. Anybody have any other ones that you want me to bring up right now? Because we also have some of our students from MSSEA who will be here too. And I want to be cognizant of protecting Ting and Andy and Mary's time as we get near the end of the hour. Are there any last minute questions or comments for the faculty here? Yeah, Nicole. Yeah.
Ting, go ahead.
Yeah, go ahead. It seems there's a question related to the sustainability. It's wonderful to see that the younger generation, you all are so passionate about it. And I don't think there's a less or more opportunity in sustainability or green economy in any given discipline. And in fact, it has to be a synergized effort to solve that problem. So there's a plenty. We have people doing with battery in our department. I happen to be doing plastic recycle degradation and the carbon capture, electrochemistry, all those things. I think they all going on in pretty much any given department you are interested in.
I think there's a question in the like kind of organic world. Do we require Ocam? We don't, but if you were going to go into soft, polymeric materials, things like this, you probably would want to take that. But I started taking Ocam when I was an undergrad, and that was not my bag. So I went to the physics route, and I went and did solid state physics instead instead of Ocam.
I think it's
Like looking in a
Ocam.
mirror.
Yeah, Ocam for soft matter is really, really valuable,
Yeah.
but it's not required. It's recommended for, and it's a must if you want to get into plastic business.
Other
there's
pressing
one more-
questions.
There's
Yeah,
one more
please.
that might just be a quick yes, no about, so if you haven't done research or had many opportunities to do projects like that, but you do fulfill the requirements to transfer, are you still competitive for an MSc application? Yes.
100% yes. There's
Come to
no
us.
expectation.
Research.
We'll teach you how to do research. That's our jam. Last questions here before we pass it on to our students.
I just wanted to quickly speak to the benefits of being part of a smaller department. You'll notice, those of you that are prospective students, that you've got 4 faculty members here and at least 1 staff member. Taking time out of their day to speak to such a small group, which a lot of the bigger departments and the more impacted departments don't do. And I think that's a great show of the level of support and the ability to get to know faculty in a small department. Something like MSc at Berkeley, you've got the benefit of being on a huge prestigious campus with so many people, but the smaller community, the fact that we all know Thomas from Laney College, I think, says a lot about not only the types of students that apply to MSE, but the opportunities that exist to get to know faculty. You're talking classes of 45 people versus chemistry classes of hundreds or CS classes of thousands. And so I think it's a really great option, especially for those of you considering Chemi to, maybe look a little bit more into this field.
Yeah, I agree. Thank you. That's good perspective. So why don't let's thank Professor Scott, Professor Zhu, and Professor Miner for helping us today. Thank you all for helping out. And let me take a second and say a word about MSEA. So MSEA is our undergraduate student organization. They are a huge asset to our department. They are kind of like our right-hand people in connecting with the undergraduate population. They have a huge number of events to build community. Faculty participate in those events. There's dinners of the month. There's game nights, which I'm on a win streak. I've won the last 2 game nights. My team has won, just for the record. So they do a lot of great stuff. So why don't we let the MSEA folks introduce themselves real quick. Mary, Ting, and Andy, if you have to jump off, please take off, and thank you again for your time. And then I'll jump off once the students get started.
Thanks,
Thanks
everyone.
everyone for the great questions.
Yeah, thank
hope
you.
to see some of you later on
Yes,
campus.
all of you in the fall. We're all
right.
welcome.
Bye, everyone.
Great. All right. Bye. Yep.
Hi, everyone. Thank you, Professor, for introducing us. The warm welcome. But yeah, I mean, I think as Dr. Martin said, we're from MSEA, which stands for the Material Science and Engineering Association. And as Professor Martin mentioned, we are kind of the undergraduate student association for the department. So we put on a lot of kind of events, so centered around professional development, kind of academic, building a stronger sense of community within the department, all of these things. So I guess basically the idea behind today was we would be kind of a panel, a student panel. So any questions that maybe you felt were better addressed to students, or maybe that you don't want professors to hear,
I'm gonna leave.
you can ask us. So we'll go ahead and quickly introduce ourselves.
So maybe
yeah.
I'll take off at this point. So you're in great hands. If you have any other questions, please feel free to reach out to myself, to Professor Scott, or Medina. We're very happy, to help out in that regard. I'll see you. Hopefully, see some of you in the fall.
All right. Yeah, so we'll quickly go ahead and introduce ourselves, and then we can just take questions. So you can always unmute. You can type it in the chat. It's kind of whatever is most comfortable for you. Yeah, so I guess without further ado, my name is Anaruda. I'm a third year MSc and EAPS major, and I guess yes, I'm the president of MSEA. In terms of, I guess we can also briefly talk about any activities we're involved in. I'm not a transfer student. I came in, the more traditional route. In terms of activities I'm involved in on campus, I am involved in undergraduate research. I also help out with, obviously MSEA, and then I'm also a TA, which is kind of, I help teach one of the big classes on campus on circuits and linear algebra, which maybe some of you will wind up taking. But yeah, I guess Daniel or Audrey, either if you want to go.
Yeah, sure. I'll go next. I'm brand new to MSEA. I just joined. I also am a transfer. This is my third year, so also just got here. But yeah, I'm majoring in material science and engineering. I'd say so far what I've gotten involved on campus is, MSEA. I just recently got an undergraduate research position, which is nice, and also just some of the recreational clubs on campus as well.
Hi, I'm Audrey. I am a freshman, so not a transfer, but also very new to Berkeley. I am involved with MSEA. I'm on the academics and outreach committee. And also around school, I joined the club sailing team.
Yeah, thank you everyone for introducing yourselves. So I guess we can just open up the floor. I guess Joshua asked how to avoid burnout as a STEM student. Very good question. I think very important question. I guess, yeah, there's a lot of chatter about what other people's strategies are. I guess in terms of Berkeley specific stuff, there are a lot of resources here to kind of help with stress management and making sure that, people are checking in and making sure that nobody's kind of overstretched or anything like that. I guess personally for me, I always try to make sure I understand my limits, not kind of overextending myself, and then taking time to, relax and always recharge. I think that's very important. And there are so many opportunities in different ways to recharge and relax on this campus, whether that's, through clubs like MSEA, or, just I like hiking, just going on drives in the Bay Area, things like that. So there's a lot of things you can do here to just recharge and relax. But yeah, Daniel or Audrey, want
to? What you said, yeah, you need to pay attention to yourself and how you're feeling, obviously. My strategy has always been to try to go really hard at the start of the semester, knowing that I eventually will get burned out later in the semester, so that I have a little bit more slack. At least that's how I've tried to do it. But there's, like he was saying, there's a lot of resources on campus to help with that kind of stuff.
Yeah, I'd just like to add that there's basically a club for like almost anything on campus. And so especially not only doing things that you like, but also doing things that you enjoy with other people who are also really into, like, say, hiking, for example. There's a hiking club, also a backpacking club. So not only can you do that on your own, but also with other people.
Yeah, and if there isn't a club for something you're interested in, there's typically people that share that interest, and you can always start one. So yeah, and then I guess Clarissa asked about joint majors versus double majors and the accreditation of both options. So from what I remember, I think the joint majors, just because of the fact that they're joint majors, are not necessarily like accredited by ABET. From what I've heard and what I've seen, nobody really cares about that in terms of industry. But yeah, I guess the joints aren't accredited, but the double majors are with respect to ABET accreditation. I'm not sure whether there was a more specific answer you were looking for. If you were, you can, add on to that. And I guess, yeah. And then Mayor asks, what do you typically study in each courses? Then, so I can quickly answer that. I mean, there's a lot of options for each. I guess this is MSc focused, so I won't go too much in depth on that, but I guess like there's a lot of lower division things like, just your vanilla circuit analysis, a lot of linear algebra and differential equations, but then from there you can branch out a lot into basically any kind of EE or CS. So a lot of good options, very strong department. Okay, interesting. So I guess Nicole says transfer students cannot double major, but you can do a joint major. Yeah, and then I guess Audrey or Daniel, if you want to comment on what your current course load is like and what topics you've learned and the other things like that.
Sure. Yeah, I'm purely MSc, so not doing a double major, joint major, no EECs for me. I did my linear, my DiffEQ, and all my physics and stuff like that at community college. So this semester I'm taking all technical classes in MSc, and it's pretty strenuous, yeah, but it's definitely like once you get adjusted to it, I've been able, at the start of the semester I was a little worried, but I'd say now once you adjust to it, it's not that bad.
Yeah, so this semester I am taking the introductory MSc course, MSc 45, that also has a lab component, and also multivariable calculus, so Math 53, and an introduction to MATLAB coding, as well as an English class. And so overall, I would say it's a larger workload than I anticipated. But I think it was good that I front loaded, especially at the beginning of the semester. Another thing I found really helpful is to make time for myself, because I know I could definitely go down the path of only studying, which would not be good at all for me mentally. So I think creating time, even if it's just half an hour to do something fun or hanging out with friends for just even half an hour a day, is better than not having anything at all.
Yeah, very good questions, everyone. Any other questions? And also feel free to unmute and ask if How did you discover MSc and make the decision to major in it? Good question. I feel like I've been going first this whole time, so someone else wants to go first.
Honestly, I joined when Martin and the other faculty were talking about this, but I actually was intending to go into Chem E for a decent amount of time, and then I actually kind of thought about it, and I started looking into like what job I would actually want to get, and then I found MSc as a major, and I realized that that's actually what I found interesting in chemistry and physics, not the jobs that Chem E and other related majors do. So that's how I decided on this one.
Yeah, for me, it was when I was researching potential majors when applying to colleges. I just thought that material science and engineering just had applications in almost every aspect of engineering, which was really nice because I wasn't really sure where I wanted to go. But with material science and engineering, I could go anywhere I decided to in the future.
Yeah, I think I 100% agree with what Audrey said. The idea that like you can really apply it to anything, right? You need materials for anything and everything. So it's applicable in almost every field. So for that, that's something that really attracted me to it. And then also kind of the idea that you can make these very small scale changes and then see these big impacts at the kind of more macro scale. So I think that's a very powerful idea. And then I guess in terms of discovering MSc, yeah, I mean, it was really just like by chance, kind of. I just started reading some kind of, I think I was reading ACS. They had like this chemical and engineering news, which is kind of like a popular science kind of magazine type thing. And they'd always have a materials section. And I always thought that that was a super cool kind of space. And then I started looking into it more, and I was like, wow, this is really cool. Any student parents? As far as I'm aware, none of us are student parents. If I'm wrong, please do correct me. No. Yeah, I personally don't know any student parents. In the department, that's not to say that there aren't any student parents on campus. I'm pretty sure there's definitely enough where there is kind of like a community, and I'm fairly certain there are organizations that work with them, but I personally don't know any or have any experience with that, unfortunately. And then Clarissa asked about research that you've done or are currently doing. Yeah, I can briefly mention kind of my research, and then I guess Daniel, you said you recently got one, and then Audrey, are you doing anything yet or no? No, that's fine. I guess, yeah, research I do, I'm in Dr. Pearson's group. So I do a lot of computational research, which is kind of modeling and simulation, and specifically kind of working with batteries and battery kind of interfaces. So I guess like if people are interested in terms of like how I got the research, the grad students also have kind of a similar student organization. So they were running a mentorship program, and I was paired up with somebody who is in Dr. Pearson's group. And then kind of I talked to him, and after a while he was like, I know you expressed interest in research. Are you interested in, joining this group? And then kind of from there, I had my foot in the door. And then I guess a couple people have asked whether for emails, I guess Audrey and Daniel, would you be comfortable with me providing your emails to the group? Yeah. And then I'll also provide an email just for like MSEA in general, and you can always kind of drop a line there, and one of us can get back to you for sure. But yeah, Daniel, if you want to talk about your research.
Yeah, let me just first start off by saying I was also worried about kind of like coming here, not having any research experience, and kind of being like an undesirable like candidate for anything. But it is like kind of amazing how many opportunities there are every day. You'll get like 3 department emails a day about people looking for interns for their like research projects, right? And I mean, I just started, if you just start emailing your resume and stuff, eventually I got one, and I'm doing, I found the thermo class I'm taking interesting right now. So I'm doing a research project on materials that can be used for like electrocaloric cooling, which is basically like solid state refrigeration. And some of the like applications of that.
Okay, cool. And then let's see. I guess we kind of touched on this. What sort of research do people work on? I don't think either of us are doing REUs. I think the idea behind an REU is that you're doing it at a university other than your home university. But yeah. Oh yeah, and then Mark, no worries. I mean, we're here to answer your questions. Any questions we can answer, we'll try to answer. And if not, I mean, I'm sure there will be other opportunities for them. Mayor asks, how manageable are the difficulty of the courses? Can you still do a semester of 4.0 GPA if you keep your nose to the grindstone, or is it just survival at that level? And how helpful are the curves?
Did you want me to go first, or?
Yeah, anyone. And Audrey, since you haven't had a chance to comment, if you want to comment, you can also go ahead.
I mean, this is my first semester here, so obviously I don't know what my GPA is going to be at the end of it. But I mean, I would say the courses are pretty difficult. at least like from my experience as a transfer, it's definitely a different level of like, you know, expectation and difficulty. But again, like once you get used to it, I feel like it's not like you're just trying to stay afloat. You can kind of manage correctly. So I don't know, that's my experience with it so far.
Yeah, same as Daniel. I have I'm not really sure where my GPA is going since I'm still in my first semester, but I think a lot of it for me at least boils down to time management. I think good time management is really key in managing all the classes, because the classes are difficult, but they're definitely not impossible. And it's just making sure that you prioritize what you want.
Yeah, I guess I can kind of comment on this, I guess, considering that I have been here for more than a semester. Yeah, I wanted to highlight what Nicole said. Getting a 4.0 isn't the most important thing in the world. Obviously, it is important to have good grades because that is something that employers and grad schools look at. But I will say, like, the 4.0 in general, it's very uncommon to have a 4.0 at this school. In my mind, actually, I think it's pretty typical for a lot of Berkeley students to have been the kind of people that always got straight A's in high school and didn't really struggle too much or were able to do well. My first semester my GPA completely, like, it tanked. Like, I got a pretty low grade in a class, and I was one of those people, you know, who in high school who'd, like, but with studying, it was not too difficult for me to get A's and maintain that 4.0 in high school. So it's definitely a very different level of difficulty. And I would say that maintaining a 4.0 isn't something you should kind of expect. And it's not a standard that that is, in my mind, at least at this school, necessarily a healthy one to hang on to. Of course, it's important to want to get good grades. And I guess in case I'm giving off the impression that you shouldn't try to get a 4.0, that's not what I'm saying, right? Of course, you should try to do as well as you can. But don't worry if, for example, you don't have the 4.0. I think it was good for me, actually, that my GPA was not the greatest my first semester, because I lost that kind of idea of, oh, I'm going to get a 4.0. So what it allowed me to do is take my classes seriously, but not to the point where, you know, I'm really, really, like, pushing myself to an unhealthy level just to maintain this kind of number. So I guess to round off, like, my comments, basically 4.0, pretty hard, good GPA, not too hard as long as you put in the effort and you take advantage of all the resources that we have here. I think a big issue with a lot of students at the school is, either because of ego or lack of knowledge, a lot of people will just not take advantage of resources and not ask for help. And that's a really important thing that I think the difficulty of a Berkeley education teaches you, the importance and necessity of asking for help when you need it. And there are a lot of resources available. I think, for example, MSSEA, we typically try to hold I guess at least when we were in person, we would hold these kind of study sessions or just kind of impromptu, like, dead week study socials right before finals, where you can work and talk to upperclassmen. We also have a Discord internally where you can chat with upperclassmen, get help, things like that. So there's a strong community. So it's all about kind of being vulnerable and asking for help. And I think if that happens and you're willing to put yourself out there and put in the effort, it's typically not unreasonable to maintain a good GPA. So hopefully that answers your question. Yeah, I guess. Let's see whether Paul and Joshua are having a good conversation. Janai asked a specific question for Daniel. How has your transfer experience been into UCB? So I guess if you want to answer that in general.
It's been good. I must say the first few months were kind of like, oh wow, it's definitely not the same as community college. And I mean, that's a normal thing, you hear that all the time. The environment is pretty, like, I don't know, I love it here so far. It's been pretty great. I've been mainly trying to adjust, so I haven't like really branched off too much to see like everything that Berkeley has in store for me, just trying to get used to it the first semester. As far as like switching majors, yeah, if you're applying, you'll notice that there aren't too many like well accredited schools that have a material science and engineering program. So yes, I did apply to like a couple schools as MSE, and then for schools that I was still interested in, but didn't have an MSE program, I did apply as ChemE. So hopefully that answers that.
Yeah, and while people are typing up more questions, I'll just send in the emails of the three of us who are here, and then just a general MSEA email, which you can email. And obviously, it's not just the three of us in MSEA. We have a lot more people, so we could have people with more diverse perspectives who might be able to share. So feel free to ask specific questions. Daniel, sorry, I'm blanking on your email.
I got it. I'll just send it in the chat.
Okay, yeah. Yeah, of course, Mayor, we're happy to help. Definitely, like, you can reach out to us even after this. Happy to answer any questions you may have. And we're here for a couple more minutes, so if you do have more questions, feel free to ask. May I ask a question? Of course. How is the housing in Berkeley? A very exciting question. Yeah, I guess I'll briefly answer this question, and maybe Audrey and Daniel can comment on it. I think Joshua's comment of good luck, I don't know that it was relevant to whether it was in response to Mayor's question, but I would probably agree with that. I don't think it's not impossible. It can be difficult to find affordable housing, but not unreasonable. I'm not entirely sure whether there is transfer housing specifically, like provided by the university, but there are a lot of resources to find apartments, right? You can do apartments.com, all of that. I mean, I personally found my apartment through word of mouth, which is pretty common. But yeah, I mean, it's not impossible, but it is difficult. And I think that's true in the Bay Area in general. Yeah. What else? I guess Victor asked for. Oh yeah. Go ahead.
Oh, sorry. I was just gonna say, not transfer specific apartments, on-campus apartments, but I believe if you do indicate, at least from what I remember, if you do indicate that you're not intending to live off campus, there are some apartments that you do get like priority almost, yeah. If you do intend to like try to live on campus, definitely indicate that, because I indicated that, it wasn't my first choice and then never got a housing offer. So definitely definitely make sure you indicate which one you definitely plan on doing, because the housing here is kind of competitive, at least from what I saw.
Yeah. Let's see what else. Okay, Shafiel asks, do most students take the local transportation like BART? I think most people live close enough to campus that we don't really need to take the BART. I think the BART is a pretty extreme. I don't know many people who need to take the BART. However, a lot of people use the bus system. I'm a huge fan of Berkeley's buses. I came from a more suburban area that had essentially zero public transport. But the really nice thing about Berkeley is you get a Clipper card, which basically allows you to ride all the Alameda County buses for free. So even if that's oh, I saw a bus, and even though if I'm walking to a place that's like 5 minutes away, oh, I saw a bus, I can just hop on and take it 2 stops because it's free for me and quick. So the bus system is really robust. Yeah, but I guess Audrey, Daniel, if you want to comment on that.
The campus shuttles are admittedly less robust, but they are extremely useful.
Yes.
Like I'm 15 minutes from campus, like off campus, and like 25-minute, 30-minute walk from the engineering side of campus. But there's a shuttle stop like right outside my apartment, and I can take that to class every day, and it takes about like 10 minutes to get there using the shuttle. So it helps a lot.
And then I guess it is 1:30, so if Audrey or Daniel need to hop off, you can go ahead. I'll quickly answer Josh's question.
Oh, I think his internet might have died. At least for, oh, also for the previous question for transportation like BART, maybe not to actual school, like the college campus, but it is really useful for just getting around in the Bay Area in general, like stuff to do over the weekend for sure.
Yeah. Also, just had to add one quick thing about the shuttle is that it does also go at night. So if you ever don't feel safe, you can make sure to look up the night shuttle, and there's also Bear Walk, just if that was also another concern.
Awesome. I think with that, I might wrap us up for the day just because we are at 1:30. You're back. Is that okay?
Yeah. My internet just cut out, but yeah, I mean, I was gonna wrap up after that question anyways.
Awesome. Well, go ahead and answer it if you want.
Yeah, I guess really briefly, basically, yes, pursuing a minor is possible. I think just like with anything beyond regular course load, right, you got to plan for it. Make sure you understand the requirements, the overlap issues. We have engineering student services counselors who are kind of dedicated for the major and are very, very accessible and very helpful. I guess, Victor, did we miss your question? For types of work is material related to chemistry somewhat. I think material sciences has chemistry applications, if that answers your question. But yeah, I guess to just round things off, thank you everyone for joining. If you have more questions, please feel free to reach out to email. We're definitely happy to answer any questions. Thank you, Audrey and Daniel, for joining, especially on somewhat short notice. Yeah, hopefully this was useful, and of course, thank you to the department for hosting this. And hopefully, we'll see a lot of you on campus next fall.